Hello friends, today in this video we are going to see aim of a sample, types of samples and the sampling distribution. So don't skip the video and watch till the end. The aim of a sample, that is, refers to the key objectives of selecting and analyzing a sample when testing a hypothesis. So these aims includes representing the population, reducing cost effect, ensuring statistical inference, minimizing errors, facilitating hypothesis testing, allowing generalization, ensuring reliability and validity, right? But what these things actually mean, right? Representing the population, that is, the sample should be a fair representation of the entire population to ensure reliable conclusions, right? Then the reducing cost and effect is nothing but testing a hypothesis on a sample instead of the whole population reduces time, cost, and resources. Then ensuring statistical inference is a well chosen sample allows researchers to infer population characteristics through statistical methods. Then the sample should be large and random enough to minimize sampling errors and biases. So this is minimizing errors. Then facilitating hypothesis testing is the sample helps in determining whether to accept or reject a null hypothesis based on statistical test. Then allowing generalization is nothing but the results obtained from the samples should be generalizable to the whole population with a known level of confidence. And ensure reliability and validity, that is, a good sample ensures that the hypothesis process, testing process, is both reliable and valid, right? So what are the types of sampling? There are four types of sampling, that is purposive sampling, random sampling, stratified sampling, and systematic sampling. We'll see each. What is that? What is purposive sampling is that, also called judgmental sampling. It's a non-random sampling technique where researchers initially intentionally select specific individuals or groups based on certain characteristics related to the study. And it is commonly used when a specific subset of a population is needed for in-depth analysis, right? Like, for example, a researcher studying the effects of a new teaching method may purposely select students who struggle with math or any subjects rather than randomly choosing students from entire class, right? So this is purposive sampling, that is, it has a purpose, or it may rely on any particular identity, right? So this is called purposive sampling. Then random sampling. So this is a method of selecting a subset of individuals from a population where each member has an equal chance of being chosen, right? Random samplings like random probability, right? Each sample, or that is each individual, right, from a population has an equal chance of being chosen. So this ensures equal probability, as I said, unbiased selection, representative sample, eliminates systematic bias, right? It ensures equality kind of thing. Then what is stratified sampling? So that is a sampling technique in which the population is divided into distinct groups called strata based on shared characteristics. A sample is then randomly selected from each strata in proportion to its size in the population. In educational research, right, a researcher wants to study the academic performance of a high school students, right? So instead of selecting students randomly, they divide into a specific strata based on grade levels, right? Strata means distinct subgroups. Say, for example, strata 1 will be ninth grade, strata 2 will be 10th grade, strata 3 will be 11th, and strata 4 will be 12th grade students. Now they can, right, they will just randomly select the students proportionally from each grade. So this is one of the example of stratified sampling, right? Then what is systematic sampling? So it's a probability sampling method where elements from a population are selected at regular intervals, right? Systematic is regular intervals instead of random selection. A fixed sampling interval is used to choose every sampling interval element from a sequence, right? Quality control in a factory, checking customer satisfaction in a mall, hospital patient record study, school attendance checking, election polling, library book inspection, restaurant customer feedback. So these are certain examples of systematic sampling, right? Because these are systematic sampling are easy to implement. It's less time consuming than random sampling and ensures even coverage of the population, right? Now, another quite important topic, that is sampling distribution, right? So, what is this? Now, from a population, a number of samples are drawn of equal size n, right? Now, the mean of each sample is measured and found that they are not equal, right? The n is nothing but equal size, that is samples, right? Where each sample has different number of elements in it. So, the mean of each sample is measured and found that they are not equal, right? The means are grouped with their respective frequencies, right? That is, with respect to the frequency, they have been just grouped, right? Not according to the number of samples that has been present in the population, but with respect to the frequencies, they are grouped. This frequency grouping or this frequency distribution is so formed is also called as sampling distribution, right? It's a general definition. Then what is standard error, right? The standard error is defined as, it is the standard deviation of the sampling distribution as we seen before, and reciprocal of this standard error is also known as precision. So where it is used, it is for assessing the difference between expected value and observed value, right? So as we seen, right, the values or the range of the sample is being grouped, that is, which is respective frequencies, a similar frequencies are grouped together in the sampling distribution, and the standard error is nothing but the deviation that is present, a mild deviation or a major deviation that is present is called standard error in the sampling distribution, right? We'll just see the sums. When we see the sums in depth, we can understand easily what these kind of things are. Then for large samples, z equal to t minus e of t the whole divided by, there is standard error of t, right? Again, that's a general formula, you just need to remember this, right? Now we came to the end of the video, right? Do subscribe my channel and just understand these definitions and do memorize, because this may come in your 2 marks or whatever the minimum marks that has been in your question paper as definition of each and everything. And for the detailed answers, we'll just need to solve the sums in the next, so that you can easily understand what these are, right? We'll meet in the next video. Do subscribe my channel. Thank you.